You step outside for some air, glance up, and your brain stutters. The moon isn't behind a cloud, it isn't a sliver, it isn't anything. It's gone. Streetlights feel a little harsher, the sky looks too wide, and the photo you snap captures only stars where a familiar face should be. News alerts confirm what your eyes refuse to. Global reports say the moon is missing. Let's walk through what actually happens next. Not the movie version with meteors and screaming, but the real version, strange, survivable, and full of consequences. The first change is immediate: tides. Earth's tides are a duet, with the moon on lead vocals and the sun on harmony. Remove the moon and the ocean still rises and falls, but with roughly a third of its usual range. High tides aren't as high. Low tides aren't as low. Harbors that rely on strong tides to flush themselves out start to look sluggish, and tidal power stations look more like decorative fountains than energy sources. Along rocky shores, the splash zone where barnacles, mussels, anemones, and starfish live feels wrong. Many species survive, but schedules slip, feeding windows shift, and any animal tuned to a powerful daily pulse has to adjust to a softer beat. Fishermen adjust their timing, port pilots rethink tidal windows, and charts slowly update to a world with smaller swings. Night itself changes character. A full moon can drown out faint stars. Take it away and every cloudless night looks like the best stargazing you've ever had. City parks feel darker, rural skies look like planetarium domes, and the Milky Way shows up even for people who've never noticed it before. Astronomers sprint outside grinning and then fall quiet because something beloved is missing. Wildlife notices too. Predators and prey that use the moon as a dimmer switch find themselves hunting and hiding under a deeper dark. Some owls become bolder, others sit tight. Small mammals risk crossing open ground and discover the odds have changed. Shore nesting turtles lose a useful cue on the horizon and rely more on the sounds and slopes that point to the sea. Coral reefs that coordinate mass spawning by lunar timing miss their conductor and slip off rhythm. None of this is universal catastrophe, but it is a planet full of tiny recalibrations. Humans feel the cultural ripples right away. Our calendars grew up under lunar light, and our language did too. Month, honeymoon, lunatic, they're all fingerprints of the moon on our stories. Festivals tied to phases suddenly have to decide what they mean without phases. Photographers lose their favorite silver halo. Romantics lose a prop and invent a new one. Werewolves start a support group. People propose a new emoji and the internet votes badly. It's funny and it's not. For thousands of years, the moon has been the night's landmark, and landmarks matter. Now, for the big fear your group chat is arguing about: orbital chaos, earthquakes, volcanoes, and whether Earth slings out of the solar system like a dropped marble. Here's the calm version. Earth orbits the sun. That doesn't change. The moon tugs on us, but it's not steering the planet's whole path. What does change is subtle. Earth and moon normally orbit a shared balance point, so Earth does a tiny monthly wobble. Remove the moon, and that wobble stops. You won't feel it, and your coffee won't ripple like a dinosaur scene, but people who track positions 2 millimeters will rewrite models and sigh. Earthquakes and volcanoes go on doing what tectonic plates and hot rock do. The moon's tidal flexing can slightly modulate the timing of tiny events, but it isn't a master switch for the deep Earth. The long-term climate question is more interesting. The moon acts like a stabilizing flywheel for our axial tilt, the angle that gives us seasons. Without that steadying hand, Earth's tilt can wander more over very long timescales, think millions of years. That doesn't mean you wake up next winter and find the axis wildly different. It means that over deep time the climate's baseline can drift more, with eras of gentler seasons and eras of greater extremes. Your grandchildren won't notice, but the far future might inherit a planet with a looser seasonal metronome. The oceans feel the loss in more than shoreline drama. Tidal energy stirs coastal waters, lifts nutrients from depth, and pushes oxygen down. Shrink that daily stirring and you don't turn off the sea, but you do slow one of its mixers. Some plankton blooms shift, some coastal fisheries see productivity change, and food webs rearrange around the new rhythm. The big global conveyor belts driven by heat and salt keep running, but the edges, where life is busy and messy and delicious, look different. Over time, marine biologists document which coastlines adapt smoothly and which struggle, and management plans adjust. On land, a quieter but very real change shows up in precision work. The solid Earth has tides too. The crust flexes by centimeters as the moon pulls on it. With no lunar tug, those solid Earth tides shrink. Surveying, construction, precision agriculture, and geodesy all use models that account for that flex. So engineers recalibrate instruments and update their software. It's not a headline, it's 1,000-line items on 1,000 checklists. Timekeepers get their own nerdy moment. The moon's tides break Earth's rotation, slowly lengthening our days over geologic time. Remove that breaking and Earth still slows a little because of the sun and other effects, but the slowdown eases. You won't gain free minutes on a Wednesday, and your great-grandkids won't either. Yet the people who ad-leap seconds to official clocks will quietly revise their timetables and send each other cheerful emails. Shipping and surfing communities adapt with a mix of irritation and creativity. In some harbors, the smaller tide range widens the safe window for deep draft ships. In others, it narrows it because of how channels and sandbars shape local water levels. Harbor masters update guidance, sailors learn the new quirks, and surfers tell stories about classic days while board shapers release a new moon line designed for smaller, cleaner sets because, of course, they do. The most important safety question is how the moon disappears. If it explodes, we inherit shrapnel, dust, boulders, a temporary ring, and a nasty spike in meteor activity. That's a very different video. In this thought experiment, the moon simply vanishes without debris. Emotionally catastrophic, physically survivable. That distinction matters. There's a quiet human upside. We rediscover the sky. With no bright lunar nights, every clear evening becomes a stargazing night. Backyard telescopes sell out, astrophotography blossoms, dark sky ordinances suddenly look like common sense, and families learn the constellations together. It doesn't replace the moon, but it fills some of the space the moon left, and that matters for how people feel about their place in the universe. Scientists get busy in all the boring, crucial ways. Ecologists watch tide pools, marshes, and reefs to see which species adapt and which need help. Marine scientists track changes in mixing and productivity. Seismologists publish papers about the disappearing lunisolar tidal signal in their datasets. Astronomers measure how much deeper their monthly observing gets without bright phases and smile through the melancholy. Coastal engineers model new erosion patterns. Safety planners add warm, low-path lighting, where full moon nights once gave trails a natural glow and use motion sensors to keep the stars visible. City councils give dark mode lighting a serious look because better sleep and better skies turn out to be a pretty great consolation prize. Engineers also get creative because engineers are allergic to leaving a blank space alone. Someone proposes high-altitude balloons or drones that paint a gentle, moving glow across parks and coasts to mimic old cues for animals that used moonlight. Someone else argues for leaving the night alone and helping wildlife adapt by protecting habitat, trimming shoreline lights, and timing human activity around sensitive windows. Tidal power firms pivot to river and current devices. Navigation device makers quietly push updates to everyone from fishers to hikers so their apps stop pretending the tide looks the way it used to. Survey firms update models for shrunken solid Earth tides. It's a million small tweaks that add up to a society-level adaptation. Sports and events tuned to tides and moonlight rewrite calendars. Beach marathons that relied on firm, low-tide sand get squishier and start earlier. Sailing regattas adjust their windows. Night bike races add reflective markers or reschedule. Night photographers mourn, and then discover that a sky packed with stars is a pretty good trade. Filmmakers rethink mood lighting. Horror directors are thrilled. The long view returns again and again. The moon shaped our history by slowing the day, steadying the tilt, pulling the seas, and writing cues for life. Without it, Earth keeps turning. The oceans keep breathing, just shallower. Life stumbles and then finds a new dance. We learn to live on a slightly different planet. Over deep time, the tilt might wander more, ice lines might creep, deserts might breathe in and out, and the baseline of climate might drift in ways future scientists will chart. That isn't a reason to panic. It's a reminder that stability is often a partnership between many quiet forces, and one of them just left the band. Because we're human, attempts to replace the moon will appear. A captured asteroid reshaped into a reflective sculpture. A thin ring of space mirrors painting a moving glow. A global art project that projects a ghostly disk into thin clouds. Most of these will fail in engineering or ethics, and the few that work will raise questions about wildlife, energy, and who gets to edit the night. The debate itself will be useful. It will force us to put a dollar value on darkness, on sleep, on stars, on the feeling of stepping outside and remembering you live on a planet. Meanwhile, the practical work goes on. Coastal communities revise flood maps and harbor procedures for smaller tides. Conservation groups adjust timelines for coral and shorebird protections. Schools update their astronomy units and take kids outside more. Surveyors recalibrate. Timekeepers adjust their leap-second forecasts. Photographers sell more star trackers. People buy more blankets and spend more evenings on the porch. The absence slowly becomes normal. In the end, the biggest shift is perspective. The moon wasn't just a rock, it was a rhythm, a calendar, a nightlight, a measuring stick for our feelings about the sky. Losing it would be like losing the porch light of the solar system. We would grieve, and then we would get curious, and then we would get good at living with a darker, starrier night. We would see how many parts of our comfort depend on quiet partners we ignore. Tides, microbes, soil, the way rocks flex twice a day, and we would get better at honoring them. We would turn down unnecessary lights, bring back the stars, and sleep a little deeper. We would protect tide pools like cathedrals. We would teach new lullabies. We would still, out of muscle memory, plan a full moon hike, catch ourselves, smile, and go anyway. And every so often we would see a bright street lamp in a fog bank and feel the tug of an old habit, tilt our heads and think, close enough. If you liked exploring a world without the moon, tap like, share this with your favorite night owl, and tell me in the comments what you'd miss most, the tides, the light, or the stories. This is Epic Explorations. See you under the stars, moon or no moon.